on page 43 with constant rate of change again today, but this is with graphs. Make sure you set up the left side for warm-up. Okay, your warm-up, this should be a piece of paper on your desk. I'm going to do a couple with you, and then you're going to do the rest on your own. Okay, the first section says, tell what point is located at each ordered pair. So when you're looking at ordered pairs, you have an x value, then you have a y value. And if you notice, the x and the y axis are labeled. Okay, number 1 says positive 6, negative 9. Positive 6, negative 9. So I'm going to count over to positive 6 on my x, and then negative 9 on my y. And it is point y. So if I were to go to a spreadsheet and check this, I would just type in the letter y. Okay, I'll do number 9 with you. It says write the ordered pair for each given point. Point O. So I need to go find point O. Here it is. So I need to look at its x value. Its x value is 8. And then its y value, which is 1. And these are both positive. So I put parenthesis 8, comma 1, close parenthesis. So these two sections you'll be able to check in the spreadsheet. The last section, I'll do number 17 with you. It says negative 7, positive 5. You have to plot the point. So this will be point L. So negative 7 over here, and then positive 5. And then it says to put that as point L. So on these last ones, you're going to have to raise your hand so those can be checked. Okay, our learning goal today is to determine the rate of change using a graph. And then our language goal, we want to read a graph and write about what a point on the graph means, what it represents. Okay, so let's look at example A. The first thing that I want to look at when I'm looking at my graph is I want to plot points on my graph. And these can't just be points anywhere on your graph. You have to put a point where all 3 lines intersect. For example, you've got your y-axis lines, you've got your x-axis lines, then you've got the actual graph, this red line right here. Okay, so I want to see, where do these points intersect? So I can put a point here, because if you notice, all 3 of these points are intersecting. So that tells me I've got an intersection of points. So I can put a point here. That shows me an exact. I can put another one here. That's an exact point. And then I just want to keep going. I want to put as many as I possibly can. Okay? So if you notice, there's an intersection. Again, all 3 lines have an intersection. Okay, so number 1 says, what is the rate of change? I'm going to show you 2 ways how to do this. You choose which way you're most comfortable with. The first way that you can do this is using a table, just like the ones you used yesterday. So you've got an x value and you have a y value. So these are my x values on the bottom. These are my y values going vertically. So my x value is 1, and then my y value is 3. Okay, let's do a couple more. So for this point, my x value is 2, my y value is 6. Let's do one more. My x value is 3, my y value is 9. Now from a table, I can find my rate of change like we were doing our patterns. Okay, so my y values are going by 3, and my x values are going by 1. So I want to do the change in y over the change in x. So my change in y is 3 over my change in x is 1. Okay, so my rate of change, I've got it, but I got to put labels on it. The y represents pounds of meat. And the x represents number of people. Okay, so my rate of change is 3 pounds of meat per, and instead of number of people, we'll just put per person. Okay, so that's one way you can find your rate of change. The other way you can find your rate of change, which I think is a lot easier, I'm going to show you how to do it using the graph. So I'm going to erase this so you can see it. So we call it, we're still doing the change in y over the change in x, but we're going to do the rise over the run. So going from one point to another, we're going to make what I call stairs. So how far I rise and run to the next point. How far I rise and then run to the next point. So let's look. From 3 to 6, how far did I rise? Well, I rose 3. So my rise is 3. And then how far did I run? So here's my run going horizontal from 1 to 2. How far did I run? Well, I only ran 1. So my run is 1. So my rise to run, how far I went up and over. And each time it's going to give you these same values. I can create staircases all the way up, my rise over my run. So if you notice, this 3 over this 1 is the same as what we put up here. 3 pounds of meat per 1 person. I like using the staircases though. I think they're a little bit easier, less work to do than the table. Okay, question number 2 says, how many pounds will 2 people eat? Well, I just got to go look on my graph, right? So I want to look, 2 people, here they are. How many pounds of meat are they going to eat? Well, here's my point. They're going to eat 6 pounds. Make sure you put units on it, please. Don't just put numbers. Okay, number 3. How many people until 18 pounds of meat are consumed? Well, I know I can't see it on my table, or excuse me, on my graph, but I could extend my table until I got to 18 right here, because this is telling me my pounds. So I can continue that pattern. I'm going to continue my pattern up here, since I don't have any space at the bottom. So 4, 5, 6, 7, 8. Let's continue that pattern like what we did yesterday. So I want to make sure I get right here until I get to 18. So it went 3, 6, 9. It's going by 3s. So 12, 15, 18. Oh, look, right here. 6 people. So my answer is going to be 6 people. So it'll be 6 people when I get 18 pounds of meat are eaten. So it looks like a lot of work, but remember, for the first question, you can decide how you want to answer it. Do you want to do a table, or do you just want to do the staircases? Okay, let's try another one. Example B. It says, what is the rate of change? Well, first let's go put our dots on our graph. Where do you see all 3 lines intersecting? I see it here. Okay, this one looks a little easier. Okay, remember, I can set up a table of the values to find my rate of change. So let's see here. At 2 hours, it was 70 degrees. At 3 hours, it was 65 degrees. Let's do one more. At 4 hours, it was 60 degrees. Okay, so let's look at what it's changing by. This time it's dropping by 5 on my Y, and then I'm going per hour. So again, change in Y over change in X. It's changing, my Y is changing by 5, and it's going down, so I gotta put the negative. And then per, let's see here, that's hours. And then my -5 represents the degrees. Okay, so I could write it as, it is -5 degrees per hour. But then remember, I can also use my staircases. Okay, my rise and my run. What is it changing by? Okay, so my rise over my run. So I'm rising, okay, this one, since it's going the opposite direction, my staircase is going down this time, that's when I know it's negative. So I'm going down from 70 to 65, I'm going down 5. And then my run, so how far I'm going over from 2 to 3 would be 1. So my rise is going from 70 to 65, and my run, I'm going from 1 hour to the very next hour. So I like my staircase again, that one's easier. Number 2 says, what is the temperature after 3 hours? Well, here is hour 3. So let's go to its point. Well, my temperature is 65 degrees. Okay, how many hours until the temperature is 45 degrees? Okay, well here it is on the graph. Here's the 45, but what would, if I extended that, how many hours would that be? So if I continued my pattern, okay, and I'm going to do it again up here. Okay, so 5, 6, 7. So let's see here. It went 60, then 55, then 50, then 45. There it is. Okay, it would be 7 hours. Make sure you're putting those units on your paper, please. Okay, so we've looked at our graph, read some points from our graph, found the rate of change 2 different ways. Now you've got its to complete, graphs 1, 2, 3, and 4. You can check your answers on the spreadsheet. Remember to only put numbers in the spreadsheet, but on your paper, make sure you include units. All right, good luck.